Okay, we're building this lecture nicely here. Let's go back. All right, here we go. I've drawn a parallel plate capacitor, all right, because I want to show you, and this is 3.0 millimeters. Okay, now, in this parallel plate, because the plates are so close together, I mean, they're centimeters to millimeters apart, the electric field is uniform. E field is the same all along here, even though we learned that for a point charge, or that the E field is equal to um, uh, epsilon naught Q, the amount of charge divided by the area. No, like that is equal to Q over echo naught divided by the area, and that's in a sphere. And as the area increases, we get further and further away, then the electric field gets smaller. But inside this thing, we're assuming uniform electric field. Okay, uniform E field here. All right. So now there's two ways to express voltage. One we've already done, and you may not understand it yet, but look, we've got joules here, we've got coulombs, and we've got electric potential or voltage. So V, two ways to represent V, units, is here's the way physicists think of it. It's the electric potential energy, the joules, divided by the charge. Okay? So here V is 12 volts. So the amount of charge that's on these things is the electric potential energy divided by the charge. I don't know what the electric potential energy is here. I just know what the voltage difference is. It's positive 12 volts as we go from here to here, and it's negative 12 volts as we go from here to here. Okay? And we're assuming that the E field is uniform. Here's another way to represent voltage too. Units on volts. Well, we'll just call it volts. But another thing for volts is it's equal to the electric field E times the distance that we travel along that electric field, that uniform electric field. This equals V. Okay. So this equals V. So let's figure out, what is the E field here? What's the E field here? If it's 3 millimeters across, and I've got a voltage of 12 meters, positive 12 meters. So my change in voltage is equal to the uniform electric field times the change in distance. Okay, so here we go. So the E field then, I'm sorry, I was trying to jump way ahead. The E field then, in this case, I don't know what it is, but I do know that is equal to 12 volts, and I know that delta D is equal to 3.0 times 10 to the negative 3 meters. So therefore, 12 volts is equal to E times 3.0 times 10 to the negative 3 meters. And so the E field is equal to, now look at this. I want to make sure I do this right. So I got 12 divided by 3 second e to the negative 3, because I don't want to get this hung up. Yeah, I thought it was 4,000. 4,000. But look what we're doing. Volts per meter. That's the same thing as newtons per coulomb, believe it or not. Okay? So the E field there, the uniform E field, is 4,000 volts. Okay. All right. So let's figure out what the voltage is what is the voltage exactly halfway through? What is the change in potential halfway through the parallel plates? Sorry, I was thinking out loud. What do you think it's going to be? In other words, if I look at these parallel plates right here, at 1.5 millimeters, what do you think the electric potential is there? 0, you're right. It will be 0. And as we get closer to here, it's going to be negative. Until we get really, really close to this guy, to the negative side, it'll be bigger. I mean, it'll be a huge negative number. All right? Because as we get closer, now I want to show you one other thing, and so we'll stop here, and I'll show you one of using the FET thing, and then we're going to go. Then what I think I want to do is I want to go through before we go to the book slides, which we may. I don't even think I'm going to go to the book slides. You can go look at them if you want, but what I'm going to do, I keep kind of rocking back and forth, don't I? My voice changes. What I'm going to do is. I think I'm going to look at this FET simulator so you can see how voltages and electric field lines work and all that kind of stuff. And then we're going to go through the quiz slides. We're going to go through all 8 of them. And then we'll look at some homework to wrap up. All right, well, I'll probably pick like 4 homework problems to do. Okay? Jeez, I'm setting myself up for a hell of a lot of work. That's okay. I love you. All right.